Welcome everyone. We are going to show you today how to use retention index option with GCLC Concordance. So as you may have seen before on the other webinar about GCLC Concordance with retention time, GCLC Concordance is a unique software that compares complex chromatograms, essential oils, fragrance, aroma, etc. in seconds. The problem: today's chromatography instruments are highly efficient, but analytical interpretation of results are still based on old manual and tedious control. Therefore, they are subject to error. Solution: an intelligent software based on neuronal algorithm solving random retention time shift. The team consists of Raymond Laurier, who made the software, and an engineer team with 30 years of experience in chromatography analysis. Typical industries using GCLC Concordance: the fragrance industry, essential oils, food aroma, wine industry, environment, oil, petrol, pharmaceutical. GCLC Concordance compatibility. Actually, it's compatible with every brand of for every brand like selling chromatographs, and it doesn't require any modification of your current chromatographic method. The key of Concordance: specific neuronal process, up to 100 million calculation for one comparison of two chromatograms. So in automatic mode, in RT and RI, we're gonna look further down at this option so you can use Concordance in retention with retention index for quality control, norm, fingerprint database, or semi-automatic, so with some settings, and retention index databases for identification, quantification, and research. So as you may know, if you have seen the first webinar we've done, GCLC Concordance solves retention time shifting in GC and HPLC, but it also converts retention times into retention index. There are two solutions for GCLC Concordance to do that. The first solution is through the integration file, which already show the retention time and the retention index. For example, Agilent software allows to convert into retention index. The second solution, GCLC Concordance, calculates the indices automatically from the retention time in the integration file. We are going to see that in a few seconds. So let's look at the process to convert retention time into retention index. So we are going to open GCLC Concordance, open a sequence. The sequence is CanQC. So we open the sequence, and I'm gonna show you basically like a chromatogram of the alkanes on a non-polar column. So obviously here we have retention time, but here you can see that we commented the carbon on each peak. So that's something you have to do only once, and next time you are using a new chromatogram of alkanes, you can put these comments onto the new one. Means like no need to name it again. You just click this button and it will put the comment on the sample here. Okay, same thing on the polar. Okay, simple. Then on we're gonna see here the one chromatogram compared to the chromatograms of alkanes, and it kind of explain how the calculation will be made. Basically, all these peaks will take a value of index depending on where it is in between the peaks of the alkane. Okay, let's go back to the slide. Now we are gonna see how to do molecular identification. So we are opening another sequence, which is this one. So here we only have the same chromatogram in the sample and reference because we are using this method. Basically, if I pick one chromatogram, it will duplicate it in this column as well. You just have to enter the index reference of index, so your alkane here. So let's delete this this line and look at our first chromatogram from a non-polar column. And there, automatically, it's, as you can see here, we have the conversion of the retention time into retention index made automatically. So obviously here we have the same because at the top we have the sample and the reference. That's for a comparison of chromatogram, but in our case we are only interested in identifying a molecule. So we are working on only one chromatogram. So let's see here, for example, if so yeah, obviously we put the value of the name of the molecule here, but let's say you don't know what it is and you want to identify this molecule. So you just click on this line, like you could on the cell, you could click here if you want to identify this line. You click here and you just do a right click. Here we have the identification by retention indices window. Basically you can find here the value of the index of this peak. So if you look at indeed the value was 979, and we are going to look at the database of molecules from a non-polar column. So this is DB5, so it's coming from the internet, so it's not very precise. So however, we can still put a threshold of plus minus 5. So if we do OK, you see that the software is selecting only the molecules in between 974 up to 984. Okay, so now we have a selection from a big database and we want to keep this selection. Perfect. Now it's done. We return to the graphic and we do the same on the polar column. The same, we are looking, if we hadn't have these comments, we could kind of realize that we are looking at the peak with an area of 1.2 around, like at least superior to 1%. So we do the same, left click and then right click, and this time we are searching into the polar database. Okay, so we have here the selection and we save this selection in with the second button. And now, miracle, the result of the two columns show that the common molecule is the beta-pinene. So then you can here comment and add the name of the molecule which has been found. So now we've done the identification of a molecule. Let's see the identification of a raw material. So we take another sequence, which is this one. So here as you can see, the method name is QC and indices. Indeed, we can do both with this method. We can do some quality control, because as you can see, we have here two different chromatograms. We have a sample and a reference, but since we are within this index mode, we also have the chromatogram from the alkane. So the big advantage is obviously you don't have to pass the alkane every time you are working on a sample, since it's been recorded at the same time as the reference, and since Concordance can sort the shifting, obviously, as you can see here, we can work even if there is not much shifting, but on the second line, on the polar column, we have a lot of shifting, but it doesn't matter. So we work with the same chromatograms of alkanes, and the relation with the chromatograms of alkane and the reference is the most important, since Concordance will find the peaks on the sample. So let's have a look now at this line, where we apparently have a little problem regarding the difference of absolute difference of area between this sample and this reference. Same thing, we left click on the cell, right click, and this time we are looking for raw material. We are looking at a non-polar column, so we are going to use actually a database of a client, which is very, very precise, so we can even narrow down the threshold to 1 and look at the results. So here we have a selection of raw material that we are going to save here, same principle as before. Then we go back to our other comparisons, which are the same chromatogram but taken on the polar column, and here obviously we are going to have the same problem. We do the same, left click, right click, and this time we are looking at the database for the polar column. Okay, we have here a selection. We save it by clicking on this button, and now let's see the result. DHM, that's the common raw material between the two databases that we found through the retention index. Now let's say you have the chemical product. You can even add the chemical product to make sure. So you cross the column 1 and the chemical. Here it could have been the Roman or the DHM. Here there is, you can see the cross of the column 2 and the chemical, and obviously the cross of the 3 of them show that it's definitely some DHM that we have in our perfume. So But here, like as you know, like usually it takes hours to identify by the mass the molecules, then check all raw materials that have this molecule. Here we have just done it in a few, like in less than a minute. When you are used to do it, it's very fast. Okay, maybe another functionality I didn't show you, like for example here or wherever. Obviously here you have also a search engine, so you can see all molecules that you have in a raw material. So let's say put orange, and you will see all the types of orange. If we look for romarin, you can see all the molecules, the concentration of the molecules and their retention index for all the molecules in romarin mar. So it could be interesting as well. Okay. So we just look at the identification of a raw material, but as I said before, we can also do some molecule identification. It's just like as we did before. You just have to select the proper database, and it will work as well here. You can look at search for molecules. So we did it before, so I'm not insisting. Okay, so let's see our last part, which is about search of a raw material in a complex chromatogram, like in perfume. This time, I'm going to close this. This time we are going to use another sequence. So here we have a complex chromatogram, and we have raw material, which is the orange deco. So obviously, as you can see, the two chromatograms are really different, but the purpose here is to see if we have some orange deco within the complex chromatogram. So what we are going to do, we are going to help the software by matching two peaks that seems really like part of like matching on the orange deco and on the chromatogram. So to do this, you just go close to your peak. You look at the index is probably here. By clicking here, you can see that your yellow bar is going on the peak, and you do a right click. Right click will save the value of the index, and you do the same with the reference, which is our orange deco, which is around 935. So indeed it opens, right click, and here you go. We are forcing we are matching manually these two peaks, very easy, and we recalculate, and then automatically GCLC Concordance find that all the peaks are indeed part of this chromatogram. Okay. Also, we can look at the area here, and if you know your product, and you can, if you are used to if you know your product, you can estimate that here like the orange deco is at the level of around like 15, 20, 25% within your mixture. Let's do the same with another one. Let's see if the mandarin jaune So here, basically, we already we did it. We matched 2 peaks, and here you can see that the peak of the mandarin jaune are all matching and all present within your mixture, your complex chromatogram. It's quite impressive. Let's do it for the armoires. So same thing, we already matched two chromatograms, like just to show you. If you want to, I'm gonna remove this match. So we are at 966. Right click, we call it, and we recover. That was the match, and I erase, and we do it. See, so without matching anything, there is no concordance. But let's match them. So it's here. We match, and then down we match again. This one we match, and we will calculate. And here you go, you find the armoire. So let's see here in the missing peak. Okay, missing peak, and here we can see there is a missing peak from which is not on the complex chromatogram. But if you look at the area, it's only a peak which is 1% within the molecule, at 1% within the raw material armoise MAR. And we know that the concentration is around, the client told us that the concentration is around like 0.5%. So obviously 1% of 0.5% is 0.005%. And actually the client gave us only the peaks above 0.01%. So it's normal that there is no matching here. Okay, so now let's do a comparison of one raw material to a library of raw material. So here we have our Citron Espagne, and here we have a library of, I think, more than 600 chromatograms, 600 raw material. You've probably seen that in the first webinar when we were comparing some wine, I think. So it's quite impressive, it goes fast. And look at all the raw materials, and instantaneously, almost, it gives you a score of comparison with all the other raw material present in the directory. So now we can open the sequence that's been automatically created, which, since it's with index, it should be lib index Citron Espagne. Citron is lemon in English. So here we go. We can find all the raw material like we saw in the report. So let's look, for example, deeply more through like the comparison of the Citron Espagne and the closest one, Citron Hiver, and here you can see there are some peak missing, but with a lot of pink peak like matching. Okay, so I hope you appreciate this presentation. I don't know if some people have any question here. I will finish the presentation here. So as you could see the benefits of GCLC Concordance in retention index for your laboratory. Indeed, it shows like how you can improve and simplify the molecular and raw materials interpretation of complex chromatogram products, increase the accuracy of the molecular interpretation by crossing the result in between polar and non-polar databases, speed up dramatically the fingerprint identification among thousands with retention index, increase the speed of identification of raw material in a mixture with semi-automatic matching. We saw that by matching two peaks manually very quickly. And you can save your standard samples for years, as well as your retention indices database. If you've seen the webinar about the retention time, you know already, I invite you to watch it. You can improve the quality control of perfumes and aroma in gas chromatography, control the composition of sample following the norms and specification imposed by your client, and can do some automatic comparison of complex chromatogram fingerprint to thousands of them within a few seconds. So like it's a new feature that doesn't exist apart from with GCLC Concordance with electronic nose. You can find the origin of a product, work on counterfeiting, and so on. The price of GCLC Concordance is 4,600 in retention time mode. There is a 450 euro for the installation, training, support and updates. And the part we've seen today, the retention index option, is 2,200 euro. Okay, so if you have any question, please feel free to contact us. On the website you also have I think our phone number. Thank you very much for attending this webinar, and we are looking forward to answering your question by email. Thank you. Bye-bye.